one thing I often hear, which is obviously incorrect if you know what's going on, but I often hear people say, this isn't a problem anymore because we're not using 32-bit systems. That's
Yeah.
obviously not correct. But why is that not correct?
Yeah, so there's one part that is improved for 64-bit systems. That's in glibc. You have this type called time_t, and this time t is 64 bits on 64-bit systems. So that part is fine. So everywhere where your programs use time t correctly, everywhere that's dealt with. That's fine. But then you start sending stuff over the network, and your network packet has a defined binary structure, and maybe that defined binary structure was made at a time when people thought, yeah, 32 bits is enough for this kind of thing, and like SNMP did it, or this XML RPC, also called SOAP, and that has types for characters and for strings and for 32-bit ints, but I think it didn't have a type for 64-bit int. So if you transmit a time and just use trivial 32-bit int to transfer it, might run into trouble. So there's these transfer formats or file storage formats. MariaDB had this problem where they store timestamps somewhere and they have a fixed binary format, and they didn't want to change it to 64-bit because that would break backward compatibility. So they did a different fix, which was to redefine it as unsigned int. So it runs for another 68 years. Yeah, that's fine. That's a long time in the future, you know.
Right. Surely no one's going to be using it in 64 years from now.
Hope. No, I think they can figure out some other solution.
So I was going to ask, there are temporary stopgaps that can be done, like dropping the signed integer.
Yeah, replacing it with an unsigned integer. That's another project just did that last week. That was the SOAP something. They also had some log keeping internal stuff, but it was a binary format, 32-bit, and they didn't want to mess with backward compatibility. So they just said, okay, it's not signed int anymore. No, it's unsigned int. And all the previous values keep working because the top bit is 0 still at the moment. And once there's a 1 bit, hopefully everyone will have upgraded. It's still nearly 12 years, not anymore. Yeah, every year on January the 19th, I say, let's remind people that next year it's only 11 years left.
Maybe at some point people will start, caring about the problem. Maybe.
No, they already start. So
Okay.
I see patches being done. When I did the post, someone said, "Oh, there was patch in grub with a new release recently, and grub does this own calculation for conversion of timestamps to an actual date because they don't have an operating system to rely on at that point." And they fixed the calculations there.
Now, 64-bit might not sound like it's that much larger than 32-bit, but the number, because it is, you do this to a power of 2, right? Just how long is this for anyone who might not really know how little of a problem it is anymore if you go with a 64-bit number?
Yeah, let's say long enough. The sun will be out and the Big Bang will long be forgotten. And maybe you can even reference timestamps before the Big Bang, which nobody ever needs, but yeah. The 0 is still at 1970.
Basically, you have more than enough numbers at that point where it's... Look, if we outlive the current universe and move to another universe and somehow are still running the same software that hasn't been updated in billions of years, I guess they can worry about it then.
Yeah, I think we will run out of IPv6 addresses before that.
Maybe we'll finally make IPv6 the standard by then.
Yeah, it's at 50% adoption or something. I'm still waiting for someone to run an IPv6 only server for something that people really want, like, that adult stuff. And, and then people will be incentivized to finally adopt IPv6.
Yeah, I guess that's what we So, okay. Why did you start getting interested in identifying these problems?
Yeah, let's say I like things to be correct, and I did this whole operating system automated testing thing to ensure that our OpenSUSE releases are correct and working, and then I tested for reproducible builds where I found actual bugs in the build process. Where sometimes, there was an error and we didn't check for it. So, no, you have 40 man pages binaries in your package and you never noticed because it's only randomly 10% of the time or something. And I found these things and for the produce builds we tested in the future, you can still get the same binaries as today because sometimes there's a year embedded in, that's not copyright 2027 because you put the current year into the generated file and that's weird, but people do that kinds of stuff or just timestamps. And I noticed that some packages failed when I built them past 2038. And I looked into that and found that there's actual instances of this issue even on x86 64. So even with a large time t, but people convert this time t to integer and do things with it because int is the default type in C programs.
And is that a 32-bit int?
Yes.
Right.
Standard int in C is 32-bit. There's a long type, and on 64-bit systems, long is 64-bit, but on 32-bit systems, long is 32-bit. So it's not enough for tracking time. And if you really want to be sure, you use long, and then it's definitely 64-bit.
Why are they doing those time to int conversions?
Maybe they just didn't think about the type thing. Or there's the standard C functions, for example. There's one called A to I, ASCII to integer, and that returns an integer from an ASCII, where you have maybe your config file or your HTTP request with some number, and you get this number in, and you throw it at your A to I function, and it gives you back your integer that got converted out, and it works fine now. And after 2038, it doesn't work.
Right.
So you need to use the write function, the A2L, the long version of it. And then I did some patches in that direction as well. And there's some pending patches too.